sample SRTM, and I will save this file, profile points, and then put SRTM. Save, run. So now I created this SRTM. I have all these points that were created. There are only 24, so meaning that's about 24 kilometers profile, and the SRTM along all these points. So let us also add the groundwater flow, which is derived from the cubic spline. So I will again sample the raster value. So it's my profile Kabul West points SRTM, and I will, this is the Kabul West cubic spline first. I say HH first. I run it so that we add it later on. Change parameters. This time I have to do the sum. As many sampled. Sorry. As many sample, which is not good. Then you don't know which one is the one that you want. Remove those. Go. Sample raster value. Kabul West last. And this will be the HH last. Saved file, and it's profile Kabul West points SRTM with HH. So now we should have a table with also the hydraulic heads for the first and the last measurement. Now, as for we said previously, we can open this as a DBF file into Excel. So open. Profile, this one. And now, again, the same as if you were doing a graph, but I suggest you to make it like longer, because it's going to be like a profile. So here you can select the data on the X. So this one will be the topography. On the X, oh, I put it too small. Second. You have here your first column is the distance, so it calculates your distance for you. So your first series will be the topography, X will be your distance, and Y will be your topography, which is the SRTM that you have extracted. And then your second series will be the HH first. So again, the X will be your distance, and the Y will be your HH first. And then you add another, which is the HH last. distance, and your y is the last. So now your first one here, your first series, the topography, hopefully. Should be interesting format. This should be your topography. Color black, sorry, and marker, you don't actually want the marker, so no marker, but you want a line. Look like too nice. It's nicer when you do maybe more close. A longer profile with a 1000 meter distance is nice, or a closer profile with a shorter distance. Because like this, the resolution of the topography will be a little bit better. And here you have your first and last measurement, which, as you see, has some issue in this area, which goes out of the topography. Weirdo, eh? So is it something, yeah, I mean, that has some meaning? Or is it actually something that is completely given by the bad interpolation of the data? It should be somewhere here. Probably somewhere here. Now, maybe I show you the other profiles that I did over Kabul, which looked nicer. Yeah. So as you can see, this is a profile that goes from southwest northeast. So this profile was done more to understand how it works between these western and eastern aquifers. Is there an interlinkage? Is there a flow between here and there or not? So to understand a bit if there was this possible interbasin flow. And I've taken a bit of time to look into the geology and also I mean, we don't know much about the deep geology, but I was a bit interested in understanding the surrounding, the kind of structure that it might be. So all these are, let's say, the very interpreted profiles. Which are the geological profiles where I asked myself if in the lower section of these two basins, there might be some old sandstone and limestone, which are the same that we found here in the upper mountain, or not. And then, sorry? This one. And yes, in the middle here is the Precambrian basement, which you see here. No? Yeah. So then we have the Pliocene, conglomerate and sandstone. So these are the Neogene sediments, which in literature say that they can go up to 800 meters depth, or actually thickness, if I'm not mistaken. And then the quaternary on the top. And then, as you can see, I have projected. So here is the profile, the graph profile. I did it exactly in the same way as I showed you at the moment. So it's quite nice. I mean, it's more high resolution. I mean, it's not like the one that I just did for you. Anyways, and then I projected the levels of the groundwater, where you can see some areas that there is more difference between the first measurement and the last measurement than others. And especially one recognizes that in this area and this area, there is more differences between the first and the last measurement. This is one profile, then the other two. So these are along, so orthogonal to the groundwater flow. So the first one is the western and the second one is the eastern. So again, to have reconstructed geological profile with the topography, and here the changes between the two first and last measurements given by the interpolation. And again, you can see that in the northwest and in the northwest for both western and eastern aquifer, the biggest changes have occurred